This question asks us to find the muzzle velocity of the pellet, that is, the velocity of the pellet right after it was fired from the gun. To find this information, we will first use conservation of energy and the information given about the swinging motion of the block and the pellet to find the velocity of the block and pellet just after the collision. Then, using conservation of momentum and this velocity we just found, we'll be able to figure out the muzzle velocity. The first step is to find the final height of the target and pellet, and this will be needed so that way we can find the initial velocity of the target and pellet right after the collision. Looking at this diagram here, we know that this distance is length L and this distance is length L. We see that we can split up this length into two parts, one which is equal to L cosine of this angle theta here, and the other into some distance h, which is how high the target and pellet have risen after the collision. Writing this down into equation form as I've done here, we can then solve for the distance h and simplify to find that the target and pellet rose a distance of L times quantity 1 minus cosine theta. We can now use conservation of energy to find the velocity of the pellet and the block right after the collision. Initially, all energy is kinetic, so we can write the energy of this part of the system as 1/2 times the sum big M plus little m times the velocity squared, which is what we're going to want to find. We set this equal to the final energy of the system, which is the gravitational potential energy of the block and pellet after it's risen a distance h. Writing this in equation form, we have big M plus little m times acceleration due to gravity times the height h, which we just found. Solving for the velocity, and then substituting in our expression for h, we find that the block and the pellet were going a velocity equal to the square root of 2gl times the quantity 1 minus cosine theta. Now that we know the velocity of the block and pellet after the collision, we can use conservation of momentum to find the muzzle velocity of the pellet. We let the initial state of the system be right before the collision. The momentum of the system in this state is then just equal to the momentum of the pellet because the block is initially stationary. So we write this in equation form as the mass of the pellet times the velocity of the pellet. We let the final state of the system be just after the collision. In this case, the momentum is this total mass of big M plus little m times the velocity, which we just found. We can substitute in the expression derived above for the velocity of the block and the pellet and solve for v0. Then, substituting in the values given in the problem statement, we can evaluate to say that the muzzle velocity of the pellet was equal to 200 meters per second.